Have you ever wondered how a bipolar transistor works? Well, I'm going to try and explain it using a 3D printed prop. The bipolar transistor was created back in the 1960s, and it now comes in many different shapes, sizes, and packages. It was originally created to replace the big bulky vacuum tubes, and it allowed things like a transistor radio. Back in the 60s, you could carry music around in your pocket. It was huge. Of course, we take that for granted today. And home computers. We wouldn't have home computers if the vacuum tube didn't shrink down to a transistor. Now, I could explain how a transistor works, talking about p-n junctions, depletion regions, electron flow versus hole flow, and then talk about base current and collector current, and calculating the amplification gain and whether it's in saturation mode. And you know what? I'd probably lose you right about now, or I'd put you to sleep. So rather than do that, let's start over. A 3D printer is perfect for making custom props. And so I went to Tinkercad, and this is what I designed. This is what's in my head of what a transistor is. It's got a base channel and then a collector and emitter channel. And imagine these are for water flowing, representing current. And then I've got this paddle designed that a little bit of flow at the base will produce a lot of flow at the collector emitter. So here's the finished prop, and it came out really good. And then here's to the right is a couple transistors, and then to the left a snap circuit, which actually has the collector, base, and emitter brought out to snap, so I can use that in an actual circuit. But let me show you the prop again. So a little bit of movement here on the base produces big movement at the collector emitter, and that's the amplification of a transistor. But if I push it all the way, it becomes a switch. So let's go deeper into this. The first mode I want to talk about is saturation mode. That's where the transistor is used as an electronic switch instead of an amplifier. Here's a typical circuit where a transistor is used to control an LED. The key point is you need 0.7 volts across the base to emitter before it turns on. And that's the point where my little flap in the base channel of my 3D print starts to be pushed, allowing current to flow through the collector and emitter. Now your Arduino is probably going to put out 5 volts. That's why you need a resistor to drop that extra 4.3 volts and also limit the current. Now current starts flowing through the LED, but it's controlled by the amount of current going into the base. And if you put the maximum current into the base without blowing it up, then you'll see 0.2 volts dropped across the collector emitter. So a very, very low voltage. And so it ends up looking just like a perfect switch or close to perfect switch. So that's how saturation mode works. Now let's look at this on the 3D print. The current from collector emitter is stopped by the gate, but as soon as that 0.7 volt threshold is reached and the current starts to flow on the base, then it's like the gate opens up and current can flow from the collector to the emitter. And here's the circuit using snap circuits. I got the resistor going into the base, the emitter is connected to the negative side of the battery, positive side of the battery comes to the switch, and also down through the motor into the collector. So now when I press this switch, it's going to allow current to go through the resistor into the base, and that's going to start current flowing through the collector and emitter, and that should turn the motor. And it does. To make this more visual, let me put a propeller on top of this guy. So now when I press it, the propeller will turn, and when I let go, it flies away. A bipolar transistor can also be put into active mode, and that's where it acts as an amplifier, where a small amount of variable current at the base can produce a larger variable current at the output. So here's an example. The input current is a sine wave, and it's small, but the output between the collector and emitter will actually turn out to be much larger because of the amplification. And here it is demonstrated once again on the 3D print. A small waveform at the base causes the lever arm to go up and down, which is the amplification, causing a variable large current at the collector and emitter. Here's a very simple circuit built with snap circuits again. The motor is going through the collector and emitter, but for the base I've got a potentiometer between power and ground. So as I slide the potentiometer, it'll vary how much current and voltage goes into the transistor. So by varying that, I should be able to control the speed of the motor. I'll do this again with the propeller so now we can visually see the different speed by watching the blades. You can almost see the blades when it starts to slow down. Lower the current and it shuts off. The 3D print helps show the theory behind how a transistor works, but if you want to actually use a transistor or design with one, you should always refer to the data sheet. It'll tell you the pinouts, it'll give you a schematic symbol, and then it'll give you a ton of electrical characteristics that you can use to design the proper circuit. Now, let me look at just a couple things here that I talked about. Remember the voltage of 0.2 from collector to emitter? Well, here it is specified in the specification. Voltage CDE of saturation is 0.2 volts. Now, I also talked about the gain, and that's the lever arm of my 3D print. And I called it HFE, and here it is, HFE. It's sometimes called beta. And in this case, it's 60. So 1 milliamp at the base will produce 60 milliamps from collector to emitter. There you have it. A 3D print helped explain a rather difficult topic. I hope that helped explain to you how a bipolar transistor works. So that's it for this week. If you like what I'm doing here, check out these videos that are popping up. Click on them or click on the Patreon logo and donate $1 a month. It really helps, but if nothing else, click on that CHEP logo and subscribe. That way you don't miss an episode. That's it for this week. I'll see you next time on Filament Friday.